I'm excited to present the Intelligent R&D Data Research Platform, a strategic blueprint for transforming the way to segment patients for research, development, and clinical trials. This is a unified, multimodal knowledge foundation built entirely within BigQuery, paving the way for faster insights and smarter trial designs. The core challenge is connecting patients to multimodal and heterogeneous R&D datasets and clinical trials. Currently, vast, complex, and disconnected data leads to difficult patient matching and drives up research and development costs. The core problem is fragmented data, including unstructured text and siloed databases. Our strategic goal is to build a generalizable, AI-ready foundation that integrates and harmonizes complex sources for patient segmentation across multiple diseases and enables model-driven trial design modifications. Our solution is a unified multimodal platform powered by BigQuery's analytics engine using 4 pillars: relational SQL for structure, graph analytics for relationships, semantic understanding via vector search, and generative AI for synthesis. This eliminates data movement and enables complex, multifaceted queries. The interactive demo showcases 4 critical functions. We will first explore the graph foundation, then the semantic bridge, followed by the multimodal query, and conclude with a strategic overview of the platform's capabilities. Welcome to this interactive demo of the Clinical Trials Knowledge Graph, built on BigQuery. In this notebook, we'll explore how this platform connects vast amounts of clinical data, from trials and drugs to disorders and mechanisms of action. As you can see, our knowledge graph is comprised of 8 node types, including 1,200 trials with rich semantic embeddings and 1,657 disorders with a full SNOMED CT hierarchy. These nodes are connected by 9 different edge types, such as may-treat relationships between drugs and disorders, and is subtype of, to navigate the SNOMED hierarchy. Let's explore the platform's key capabilities. First, we have graph traversal, which lets us match multi-hop patterns using GQL. Second, semantic search leverages 768-dimensional embeddings for vector similarity. Third, we can still run traditional relational SQL for analytics. And finally, we'll use generative AI with Gemini 2.5 Pro for powerful summaries. Take the patient journey, for instance. A patient reporting joint pain can be connected to arthritis trials through a series of graph traversals and semantic searches. Now, let's start with our first query. In this use case, a patient advocate wants to find trials for arthritis and all its subtypes. We'll use a graph pattern that starts with arthritis, finds its subtypes, connects them to drugs that may treat them, and finally links those drugs to the trials they're used in. This demonstrates the power of medical ontologies. By searching for arthritis, we also find trials for related conditions like rheumatoid arthritis and osteoarthritis. As you can see, the query instantly returns trials for degenerative polyarthritis and psoriatic arthritis, providing a comprehensive view that would be difficult to achieve with traditional methods. In this segment, we'll dive deeper into the platform's semantic search capabilities, using 768-dimensional vector embeddings to understand the meaning behind patient symptoms. Let's imagine a patient describing their symptoms in plain English. This is a common challenge, as patients don't use precise medical terms. We'll use a vector similarity search to find the closest matching medical conditions. For our input, we'll use the phrase, joint pain and inflammation with morning stiffness. A keyword search would struggle with this, but our vector search understands the underlying concepts. As we run the query, the system identifies arthritis and psoriatic arthritis as the top matches. This demonstrates the power of vector search to bridge the gap between patient language and clinical terminology, ensuring no potential candidates are missed. And that's the power of the semantic bridge. It allows us to connect a patient's experience directly to our clinical protocols, paving the way for more accurate and efficient patient segmentation. Now putting it all together, the multimodal query. In this segment, we'll demonstrate the true power of this platform by combining all 4 capabilities, semantic search, graph traversal, relational SQL, and generative AI into a single, multimodal query. This query simulates a complete patient journey. It starts with a patient's description of their symptoms, finds relevant trials, and then generates a personalized, easy-to-understand recommendation. This is the entire 4-pillar platform in action. Let's break down the query. Step 1 is semantic search. We're taking a patient's description, chronic joint pain and stiffness in hands and knees, and using vector search to find the most relevant medical disorders. Step 2 is graph traversal. The query takes those matched disorders and navigates our knowledge graph to find all recruiting phase 2 and 3 trials, along with the drugs being tested. Step 3 is where the relational power comes in. We use a standard SQL join to pull the specific exclusion criteria for each of those trials. This is a critical step for determining patient eligibility. And step 4 is the generative AI. We dynamically build a detailed prompt, feeding all of this context, the symptoms, the trial, the drugs, and the criteria, directly into the Gemini model to create a personalized recommendation. Now, let's run the query and see the result. In just a few seconds, the platform has processed this entire multi-step workflow. And here's the output. We've gone from a vague symptom to a specific, patient-friendly recommendation for a clinical study on tulisokibart for rheumatoid arthritis. It explains why the trial is relevant, what to expect, and outlines clear next steps for the patient to discuss with their doctor. This demonstrates the power of a unified platform. We've bridged the gap from patient symptoms to actionable clinical insights in a single automated step, directly supporting our goal of faster, more intelligent patient segmentation. Finally, because this platform is built entirely on BigQuery, we maintain complete visibility. Here, we can instantly pivot from granular details to a high-level view of the entire trial landscape. This dashboard provides real-time competitive intelligence, allowing us to monitor market trends, validate our portfolio strategy, and identify new opportunities with confidence. The platform delivers tangible value, building strong data foundations, providing faster insights with zero data movement, and improving outcomes through semantic matching. It is generalizable and can easily span to other areas, and enables strategic trial design modifications by immediately highlighting exclusion criteria impacts. Our next steps include integrating real-world data, adding temporal analysis for patient progression timelines, and scaling the platform to cover other areas. The foundation is built, and now we scale.